All right, it's official now. We have started recording. Hi, my name is Scott Moss, and welcome to System Center Virtual User Group Meeting number 22. It's actually November 8th, 2013, and we are here with Pete Zerger and Joe Thompson, who are going to talk about System Center 2012 R2 build automation using PowerShell, followed by Christian Booth, who will get here when he gets here, hopefully. And with that, I will just throw it over to you, Joe. Take it away.
Thank you very much, Scott. I'm Joe Thompson with Infront Consulting Group, and today we're going to talk about some options that you have to help automate the deployment of System Center 2012 R2. Let me go ahead and bring up my slide deck. Here we go. So, how many people on the call have heard of the PowerShell Deployment Toolkit?
Never heard of it, Joe. Sorry.
Okay. Well, it was introduced at MMS this year in Las Vegas. Rob Willis gave a great presentation on how to automate your deployments of System Center. They also gave an additional session to MS Tech Ed that goes into a little bit more detail that you probably want to check out. The toolkit is not directly supported by Microsoft. They consider it community supported. But any installation that you do with the deployment toolkit is fully supported. There's no non-standard installations. They're all supported style installations of all the System Center roles. So if you do use the deployment toolkit, it's community supported, but once you get System Center installed, that is fully supported by Microsoft.
Hey, Joe, I wanted to just throw in another question we hear a lot, and we saw on your PDT series that you did out on System Center Central. What version of PowerShell do I need to use the PowerShell Deployment Toolkit? And along with that, what operating systems are we talking about?
You definitely want to have PowerShell version 2 at least. It does not require anything above that, so at least version 2. It is supported on Windows 2008 R2, SP1, Server 2012, and 2012 R2. The best luck I've had using the toolkit is always to deploy from a Windows Server 2012 or above environment. There is only one role that really requires Windows Server 2008, and that's the SharePoint Web Parts server. The good thing about the toolkit is it does have complete validation. So once you define your deployment, and we'll go over that here in a minute, it will make sure that you haven't done anything funny and have the right operating systems and everything required to use the product. Does that answer your question?
That does. Thank you.
Excellent. PDT is also used internally by Microsoft for all their SC demo environment builds, and I think you're going to start seeing them use it even more as they develop content for their IT training labs. So what can PDT do for you? These are all the components and roles that are part of System Center, and it will fully orchestrate the installation of all the different roles for each component. Mid-year, they also added the ability to install the Windows Azure Pack, as well as service management automation, so you can get a complete private cloud solution within your data center with the product. But before you can really get started with installing System Center, there's a lot of prereqs. There's a lot of IIS prereqs, .NET, SQL connectivity. These are all handled by the PowerShell Deployment Toolkit. I think in the presentation that Rob gave at the MMS, he listed over 500 screens in the entire process of installing the servers, getting the prereqs on, getting SQL Server installed, and then install the roles. So it's quite a time saver compared to having to do it all manually. The last full deployment of System Center I did, I think it was 55 or 60 pages of documentation and screen prints that I put together to kind of document the environment, made sure I had all the settings, documented for the customer. There's only really one file that you need to edit with PDT, and that's called a variable XML, and we'll show you that here in a second. And once you have that edited and created, there's your living document that shows how your environment was set up.
Hey Joe, so I think we're all just sort of swimming in that massive list of prerequisites. So when you deploy the entire suite with PDT, what is your active build time? How much like active effort do you think you put into that process?
It's really dependent on the speed of your Hyper-V host, as well as the memory available.
Mm-hmm.
The sessions at MMS that Rob did, I was really impressed that he was able to get it done in an hour. I immediately went home and started playing in my home lab, and 3-4 hours later.
But you're not active that whole 3 or 4 hours, right? So you're active a fraction of that, I'm guessing.
Well, you spend about 30 minutes an hour actually defining the roles that you want to install within PDT, getting the configuration for the virtual machines that you wanted to deploy as part of the process. So that's a couple-hour process. But once you kick off the process, it's on its own. You can go off and go to dinner or get you some coffee or whatever, and then 2 to 3 hours later typically is when you'll have it done. On a system that I have here at my home lab, it's a quad core, i7. It's a pretty strong CPU, and I only have about 32 gigs of RAM on my machine. So 2.5 to 3 hours later is pretty typical. But if you have a server class machine, unlimited memory for more than 32, the more memory that you can give to the VMs, the faster the installs will do. Another thing, as part of the deployment process, it's not quite as happy with the dynamic memory within Hyper-V. So if you have the memory to give to your VMs, go ahead and set 8 gigs or 16 gigs per VM, and they will install pretty quickly. So really, the process for installing System Center has a number of steps. First, you have to define your deployment, what roles you want to install on what servers, where your SQL installs will be, and that's the same whether you're doing it manually or through PDT. You have to download all your bits, and if you're doing a lab, that'd just be the evaluation bits for System Center 2012 R2. It's been kind of a rough month for the PowerShell Deployment Toolkit team in that Microsoft no longer allows you to automatically download those bits. So there is a process that has been documented where you download the bits, extract them to certain directories, and then PDT will pick those up and run with it. And those are the rest of the process that you really have to go to do a full System Center install. Looking at that process from a PDT standpoint, it's much simpler. You still have to define your deployment and get all your bits in place, but it pretty much handles everything else. So once you're done, you're ready to install some agents and actually, use a product for your private or hybrid cloud environment. So there's a lot of post-installation integrations that are really required to bring System Center together as one product. And PDT pretty much handles all the automatable component integrations that they already had. There is one notable exception in that it cannot do the orchestrator integration pack registration. There is no Microsoft-supported way to do that. There are techniques to do it, but it's not supported within the deployment toolkit. There's several different ways that you can use PowerShell Deployment Toolkit. Earlier versions really only had one mode, but now there's what I like to really call lab in a box. It gives you a complete self-contained lab environment of System Center. Using the VM creator script, which we'll go through here in a minute, it will deploy the main controller VM. Once the VM's deployed, it will set up a complete Active Directory environment. And then once Active Directory is up and operational, it will then start the rest of the VMs that are part of your System Center lab, and then join the VMs to your domain. Once all the VMs are a part of your domain, the installer will kick off and do the rest of the installation of System Center. So it's really kind of a one-click lab in the box. So that was a feature that was added mid-year, so I was really glad to see that added, because it takes a lot of the effort out of making sure that you have the prereqs available for our first standalone lab. Several other different ways you can use it. If you already have a domain-joined Hyper-V host, you can use the VM creator to create your VMs that will join to your already existing domain. Then you can kick off the installer script. It will then deploy the System Center environment to those VMs. Of course, if you already have your virtual machines created or you're using physical machines, you can still use PDT and just use the installer. It will do the same prereqs validation to make sure those machines meet the requirements for the PowerShell Deployment Toolkit. So really flexible in a number of different ways you can use the product to get your environment out there. There's a number of files that are part of the toolkit that you need to be aware of. The first one is the variable XML file that we talked about earlier. That's really where you define what you're going to install. That's components, roles, SQL servers, and virtual machines that you might have as part of that deployment. The workflow XML is really how to install it. All the components are defined in there, what System Center roles that are part of that component, what prereqs are required for that component to be installed. It will actually list the download path from Microsoft for a lot of those bits. So when you use the downloader, it knows what bits it needs, it downloads them, gets them ready to go, and then you can execute your install. Another great thing about the workflow XML is it's really a great reference in everything System Center. So if you want to know how to silently install a certain role, it already has the command lines in there that you can pull out and use separately if you wish. The downloader is what actually downloads all the requirements for your System Center deployment. If you're doing a small deployment with just R2 or just System Center 2012 SD1, you can use the deployment only switch, and it'll only download those bits that are required. If you don't use that switch, it will download everything that's defined in the workflow XML. So that would include not only System Center 2012 R2, but 2012 SD1 as well, because you do have the ability to install either version with PDT at this time. The installer is really the engine. It's the deployment controller. It's reading your variable XML and workflow XML to see how you define your deployment, and then go ahead and execute all the installations of the prereqs and everything that you need to get System Center installed. And then really the last file that's part of the toolkit is the VM creator. So if you need to deploy some virtual machines as part of your System Center deployment, it will do that for you. And again, there's two modes. If you want to do a lab in the box, the VM creator will create your virtual machines, create Active Directory, bring your machines up, and then do the full System Center deployment.
So, Joe, you mentioned virtual machines there. Is there anything we have to do to prepare for PDT to do the deployment, or does it just handle all of our VM creation for us?
The only prereqs for using the Deployment Toolkit is a installation of Windows Server 2012, preferably R2, but SD1. Or SD1 will work as well. With the Hyper-V and tools installed, as well as creating a virtual switch that your VMs will be a part of. Couple extras that you need if you need to deploy VMs as part of your lab environment is Convert Windows Image, which will actually take your Windows Server ISO and create a VHD file, which can be used during the deployment process. And I'll show that here in just a little bit. Also, you'll need either 7-zip or WinRAR, due to the fact that some of the System Center evaluation bits are actually compressed as RAR files. So let's quickly review a variable XML file, and let me get that up and running here. See if I can share my desktop. And can you see my screen okay?
Yes.
Okay. All right, so here's the different files that are part of PDT. The first one we'll cover is a variable XML. And basically, this is where you find all your prereqs for your System Center eval. You can put your registered user, registered organization information, what account you'd like to use to install the bits. And if you're doing lab in a box, it will go ahead and make sure that your installer account has all the required permissions. If you're doing a deployment to already existing domain, you just need to make sure that your installer has administrator privileges to the machines that you're deploying to. If you do the lab in a box approach, it will automatically copy all the downloaded bits to the temporary directory of the DC virtual machine that comes up first. Download is the path where if you use the downloader tool, it will download all the bits for you. So one thing to note, if you're just using the installer without the lab in a box, your source path needs to be the same as your download path because the installer also uses this location. So you're downloading the bits here. Whoops, I want to do that. So you're downloading the bits here, and the installer's looking here. So what you can do is copy this path up to that path and make sure they're the same. Then you define the components that you want to install as part of your deployment. And with each component is a number of variables that you can set. A lot of these are defaulted within the workflow XML, but if you wish to change from the default, you can change that here. Within the workflow, most of the products default to the system drive, which really in any environment you don't want to do, so you have the ability to change your defaults here. You can also specify what the admin group is, service count, and service count passwords. And that'd be the same just pretty much for every component that you want to install as part of your deployment. Next, you want to define which roles you want to deploy, and you do that within the roles section. So for every role, you want to list a server name, and in this case, it's a database server role, so we want to define what SQL Server instance it will be installed on. You also do have the ability to install it to clusters, and if you go to the Building Clouds blog, you can see some example variable files that show you how to do that. So once you have all your roles defined and the server names where you want them to go, you then go and define the SQL Server instance information. So as you see up here, we have server name SCVML1. We duplicate that information down here in the SQL Server instance information. We can specify what version of SQL, and then there's a number of defaults that we can define. So this is a very simple lab environment. You know, I have the database, the temps and the logs all go into the same drive, but in a production environment for better performance, you want to put those in different ones, spread out the IOPS.
And Joe, I think you just made an important distinction there. You said production environment, which means that unlike the unified installer that we saw last year before, we can use PDT to deploy production, yeah?
That is exactly correct. So once you do your proof of concept with PDT, you could then pretty much turn around and use the same configuration file to install in production, just changing the server names and maybe scaling it out a little bit more. Because you can scale out this installation while this lab only shows, like, for instance, one operations management server, in a production you want to have at least two. So it does give the ability to what's called operations manager additional management servers. So one thing that really gives you is whether you do a POC environment or in your company you like to do a dev or a pre-production and production environment, this way you can ensure they are consistently installed the same way. So that's a great benefit. If you have problems in production, you can go back to your POC or pre-production environment and know they were installed pretty much exactly the same way. So that really adds some consistency into your life cycle processes. And then once we get our SQL servers defined, so if we're doing a lab in a box or we're deploying the virtual machines as part of the PowerShell Deployment Toolkit process, the VM section is where we define those virtual machines and what they're going to look like. The first thing to note is that for the lab in a box where you're deploying a full domain environment, this is the key that makes that happen. So if you remove this part, if you run VM Creator, the only thing it's going to do is create virtual machines. But when you add this part, it's going to create the virtual machines. It's going to start your domain controller machine first, install your Active Directory, and then install the rest of your domain. And there's a number of defaults that you can set for every VM that you're going to create, and that's this section here. You want to define where you're going to store your VMs and VHDs. If you want generic names, you could actually put a prefix here of SC1, and it'd be SC1, 2, 3, 4, 5. Or you can individually define what the VM names are as well. In this certain deployment, I'm setting a minimum and maximum memory of 8 gigs, and that tells PDT I don't want to use dynamic memory. So at least during the deployment process, give the machines as much memory as you can. Not only will they install faster, but if you're resource constrained, sometimes you have timeouts between the different role installations. So the more memory that you can give to the process, the more successful you're going to be. We're defining what virtual switch that we want these machines to go to, as well as MAC and IP information, as well as what parent VHD we want to use for the VMs. You do have the choice of using either differencing or not. If you want them to each have individual VHDs, you can change this right here from differencing to copy. And then each VM will have its individual VHD. We're also specifying how many data drives we want and their size. And then here's the information on joining the domain. So either it's a lab in a box, or if you're using it to join the VMs to an existing domain, this is where you'd set that information. So you need to make sure that you have an account that has privileges to add machines to the domain. And you can also set the admin password of each individual VM. And in this deployment, we're installing onto 8 machines, including the domain controller. If there's a certain machine that you want or don't want to have the default that you set for any configurations, you can actually copy the code down here. For DC, we really don't need as much memory, so I only gave it 2 gigs in this case. If you're going to use the defaults, all you have to do is specify the VM name, and then the rest of the defaults will come from the section above. If you're going to install the SharePoint Web Parts self-service portal for Service Manager, that still does require Windows Server 2008. So you'll have to also create a VHD for that as well. The network adapter name for 2008 is different than it is for 2012. So they added the capability to also specify the identifier. Earlier versions of the product did not specify this, so it was not correctly setting the IP and DNS information correctly. So that's the variable XML. And then just a real quick overview of the workflow. I know there's a lot of information that's really busy, but just to kind of see how it corresponds with the information that you're putting into the variable. You have a component section, and again, here's those defaults that you define within the variable. In many cases, there's already a default value, so if you want to leave the default, you don't have to define that within the variable XML file. Also, the same for SQL. These are all the different parameters that you can specify, and they as well have default values. Of course, you really never want to install SQL onto the system drive, so that's why we set that install path to another drive within the variable. Just a real quick look at the roles. As I mentioned earlier, you still have the ability to install System Center 2012 SC1 or R2. So it's really important that when you do use the download or you want to use a deployment only, so you're only pulling down the bits that you need. Just a real quick look at the information that's included with each role. So the orchestrator management server, the validation that PDT does, it looks to make sure that in this case you're installing either to Windows Server 2012 or 2012 R2. R2 will not, in this case, install to Windows Server 2008. Also, there's a concept of combinations. There's certain System Center roles that just do not work together. One quick one that comes to mind is any operations manager role really can't coexist with any service manager role. They're very similar in architecture, so at this time you can't install that. But there's other roles that don't work well together either. So they've gone through the process of figuring out which combination of roles can work on which servers together. During the validation process, if you try to mix roles that don't belong, it's going to let you, and it's going to prevent you from going further. Then also it lists the server features that are required for the role. So before this role installs, it will install these server features before it moves on to the next step. And then at the bottom is integrations. Let's see, we've got a good one here. So for every integration between the components, it lists a dependency which must be installed first. Once that dependency is installed on whichever role server, it will then install the integration for you on that server. So it's real smart. If you want to do a small, limited deployment of just, say, Operations Manager, you can actually come back through with PDT at a later date and add VMM or add Orchestrator. As long as you have all those roles defined in the variable XML, it will detect what you have installed and then install the additional roles as well as go back and install the integration. So it's real flexible in that you can stage additional roles. It will know that and go back and do the integrations for you. Okay. See, how are we looking on time?
About halfway through.
Halfway through. Okay. Let me get my slide deck back up here. Okay. So I mentioned that as part of the VM deployment process, you do need to create a parent VHD. Here's some information on how to download the script, as well as a sample command line that you can use to get that created. If you use a command line, you just need to make sure that the paths that you choose for the VHD match the information in the variable XML. If you don't want to use command line, there's also an option to use a GUI. There are some bugs in that it doesn't allow you to specify the path for the VHD, so just accept the defaults there, and it will create the VHD, and then you can just copy it over to where you need it. So as you asked earlier, Pete, what do you need to get started? Windows Server 2012 R2 Data Center is a great place to start, especially in a lab. You need to install the Hyper-V role as well as the management tools. You need to create a virtual switch that your VMs will be a part of. Of course, this is variable. This can be any name that you want to give it. You just need to make sure that it matches the name that you have in the variable XML file. Then you need to customize the variable XML to define what roles and what servers you want to deploy. And once you get that done, you need to run the downloader, and it will go out there and download all the bits for you and place them into the installer folder that you defined within the variable XML. As I mentioned earlier, at this time you can't automatically download the Windows Server or System Center 2012 R2 bits, so those will need to be downloaded ahead of time. And I have a screen here shortly. It'll show you the location that you need to put those bits. So once you've downloaded the evaluation bits, you've gone online, registered with Microsoft, and you downloaded them, and extract them to the correct folders, you need to rerun the downloader again. What this will do for you is it'll see that the configuration manager is in the correct directory. It will go ahead and do the process of downloading all the prereqs that are part of the CM process. Create your parent VMs, and then run VM Creator, and it will go through the entire process. Create your VMs, create your domain controller, create Active Directory. Once Active Directory is up, it will start the other VMs. They will do their installations, they will join a domain, and then it will run through the entire installer process and install System Center for you. Here's the manual download steps that you'll need to follow currently. I know there's some deliberation in Microsoft about how they can, again, provide the bits automatically. So stay tuned there. Hopefully they'll get that resolved here soon, and this will be less of a problem. I'm just going to show a real quick time-lapse video of what the entire process looks like. Due to time limitations, I didn't think we'd be able to get through an hour to 3-hour deployment of using the toolkit, so at least kind of want to show you what it looks like. So let me get that up on my screen for you. Okay. So basically, begins by validating the fully qualified domain names of all your servers. And this is just the install process. It's not the full VM creator process. But at least kind of gives you an idea of the number of steps it runs through. So it makes sure that your machines are online. Make sure that all the dependencies you need for your roles are defined within your variable. Make sure all the combinations are good. You don't have service manager, combined with operation system manager. Make sure all the instances have been defined, and that you have all the variables that you need defined within your XML, the SQL variables as well. And make sure that you have your SQL instances defined that you'll need for your roles, as well as all the service accounts that are required to set up System Center, as well as security groups that the different roles require. It also makes sure that you have all the bits that you need for the installation. So if you're missing anything, it's going to let you know. And then it's making sure that the account you're using to run the installer has access to all the different servers. And so here's really the interface for PDT. There's not too much to it. It's organized by the System Center component and then the roles that are part of that component. So it's going through, at the same time across all servers and doing the installation. So from that standpoint, it runs fairly quickly. As the various roles are installed and successful, it will turn green. The yellow is when it's waiting for a dependency that has not yet been made. So the different integrations between the products, it will sit there and wait until that role is completed on the other server. Once it sees that role is complete, it will then finish the integration. And this is actually a capture of the demo that Rob gave at MMS, so I appreciate him going through this pain for me. Another thing to note is how quickly this deployment finished. And that's it. Once you're finished, this is what you want to see.
So you said this all took him less than an hour to roll the entire suite out.
57 minutes.
Incredible.
We'll have to dial it up in our lab back in Toronto and see if we can match that. So here's the contest. Anybody has a server class machine, send a screenshot of the quickest time that you've installed PDT. Let's make a contest out of it. Okay, let's get back to the content. Are there any questions about the PowerShell Deployment Toolkit?
Queue looks empty now.
Okay. So the next information we want to talk about is desired state configuration. This is a pretty big deal. This was released with Windows Management Framework 4, which by default comes with Windows Server 2012 R2 and Windows 8.1. It's more of a framework that allows you to define the desired state configuration on your servers and desktops. If you want more information about DSC, I definitely recommend the blog posts as well as the session MMS. It gives you definitely more of a deep dive than we have time to go through here. Interesting thing to note is it will not be able to be installed in Windows 8. Microsoft is expecting everybody to upgrade to Windows 8.1. So if you're expecting to use this with Windows 8, go ahead and get that upgrade out of the way, then you can start getting into your lab. The interesting thing is you can either push or pull desired configuration to your endpoints, which is great. So if you're deploying a lab, you want to get that configuration out there now, you can push it out to the endpoints. Or if you want to, on a recurring basis, make sure that the configuration of your servers is at a certain state, you can set it, the local configuration manager, to refresh from time to time. And again, there's some more DSC links, a lot of information here. The best thing is just to go out there and do some research. The session that Jeff gave at System Center Universe was great. Really recommend that you walk through that one as well. So desired state configuration has a concept of resources. So it's almost like many functions that you can define how to act on different resources with DSC. You can work with zip files, your environment, registry. Through role, you can install Windows features. Using the script resource, it's pretty much a catch-all. So any kind of PowerShell script that you can do, outside of DSC, you can also do within DSC as well. The interesting thing is you can create your own DSC resources, or pretty much like functions. So I can really see a lot of application in the System Center world to where you want to install management packs or connectors. You can create modules that would do this and simplify people's work and having to set up these files. So beyond PDT, why would we want to use desired state configuration? The PowerShell Deployment Toolkit does a lot for us. It gives us a base environment of System Center that, say we're setting up a lab that we want to use for user training, there might be additional roles and features or configurations that we want as part of that lab. and we don't want to have to go back and make modifications to the PowerShell Deployment Toolkit. This allows us to kind of encapsulate what we need for our environment apart from what the default deployment of System Center will give us. So these are kind of some of the things that you can do with DSC. Other applications that you could use DSC for is like application lifecycle management. If there's a certain configuration that you want to make sure is persisted across your non-production and production environments, you can set it up in your test environment to install Windows Server roles, IIS roles, create websites, make sure certain executables are installed. You can easily transpose that into a production environment and ensure that your environments are consistent across the board. So a lot of different applications for DSC beyond System Center, but just to kind of give you some ideas of where you can go with it. So, anatomy of a DSC script. There's really three concepts to desired state configuration. Within your PowerShell script that I'm going to show you, there's three stages. One is there's a authoring task, configuration block that you create. The different resources help you define what the MOF file is going to look like. So the configuration block is just dealing with the structure of the management operation framework file that's going to be downloaded to your local server. The next step is the actual stage or create the MOF files that you're going to use to enact the configuration. And then the third stage is to make it so, execute that MOF file locally using your local configuration manager. And local configuration manager is part of the Windows Management Framework 4 and PowerShell 4. Okay, so basically all the different configurations that I showed you that you can do beyond the PowerShell Deployment Toolkit is enacted into this PowerShell script. So basically, we're creating a secure password that we need to use for some of our operations, and hash table that defines what servers and what roles that you want to enact the configuration on. We're also creating the share, in this case on DC01, to where the individual servers can pull additional installation files for. And here's the start of the configuration block, and this is really nothing more than a PowerShell function. It works very similar. So just like a function, you can pass parameters to the configuration block, and then start the configuration of all the nodes that you have defined in your hash table above. Here's the registry resource. So basically what we're saying here is we want to ensure that this configuration is present. We're defining the key and the value type, and the data. So it's going to go through and make sure this value is set. If it's not set, it's going to reset it. The concept behind DSC is you should be able to run it as many times as you need. It should never affect the configuration if the configuration has not drifted from what you have set. We have file resources as well. You can also work on archives and unzip files to certain directories. Installing Windows features, again, you want to make sure, or you can also uninstall Windows features. So if there's certain features that you don't want to have on a machine, you can change this to absent, and it will actually uninstall that Windows feature for you. So on the SCOM, the Operations Manager server, there's certain additional functionality that we want that's not a part of PowerShell Deployment Toolkit. So we're copying the shortcuts from the default start menu to the desktop. We're installing the System Global Service Monitor Management Pack. With Operations Manager, you typically have to install the management pack before you import it. So it allows you to actually orchestrate the installation and the importation in the correct order. Because here we're installing the package, and down here you see we're actually starting to import the management pack. So there's a keyword called depends on. So this script block will not run until this script block runs. And there's basically 3 components to every resource. There's a set, there's a get, and a test. So no matter whether it's a script or a package or a file, if you look at the modules under the PowerShell directory on your local server, you'll see 3 different functions. There's a set target resource, get target resource, and test target resource. So the script block first starts off by running the test script. So first we're testing to see whether this management pack is installed. If this comes back as true, then this configuration will not run. But if it comes back as false, it will then do the set script, which is import management pack. So this would be a perfect example of the script that you probably want to turn into a module, like the file or package, to where you're just specifying the location of the management pack and testing whether it's installed or not. But you're doing that within a module and not within a script. It'll just make it a cleaner implementation. So these are all the different configurations that we can do, and again, it's organized by the server and a role. So as you add different functionality or you need additional functionality for a certain role, you can just quickly paste in the script block and then generate the MOF file. So how we generate the MOF files, this is the staging part. So System Center Build is the name of that configuration block. So it's basically like you're calling that function, and then you're passing parameters. So we're passing the hash table that we created for the servers and roles, as well as what file share we want the servers to pull their additional bits from. And we're outputting all those MOF files to a directory right here. And then the next step is we actually want to start the DSC configuration. And we're passing credentials that certain configurations need to function. And then we're also looking at the directory where we created the MOF files above. So once you create the MOF files, you don't have to run this again. You only need to run the start DSC configuration. It will read the MOF files that's already been generated. It's only when the configuration changes that you need to do something additionally or take something out that you want to regenerate those MOF files. And let's see if we can do a quick demonstration of what that looks like. Let me pull up my little lab here.
I think we lost your screen.
Okay.
Got currently nothing shared. Just wanted to throw that out. There we go.
Does that look a little better? Okay, I've already run this script that you saw in the background once, and this is basically what the output looks like. Basically, we're defining our configuration, we're compiling the MOF files, and then we're executing those MOF files locally via the local configuration manager. So another great byproduct is this: you're not using PowerShell remoting. You're doing everything local from the machine. So you can think of all the different issues that when you try to remote a machine, it's not letting you. There's a lot of configuration that you have to do to enable remoting. As long as WinRM is enabled, you're able to use DSC. So because we use the verbose switch, it gives us extra detail about what's actually happening on the local machine. So on the orchestrator server, the local configuration manager is starting to test. It's seeing if this particular configuration has been enacted. If not, it'll come back false, and then it'll actually set that configuration. So it's going through every server. It's executing that MOF file locally on every server. So another concept of DSC is being able to rerun the configuration multiple times. If the configuration has not drifted, it will not change anything. So you can always be ensured that the configuration is going to stay to the spec that you set. So in this case, I'm just running the start DSC configuration against some MOF files that I've already generated. So it's just basically going through, doing its checks. It's making sure that the configurations match how you define them within your configuration block. And because it wasn't a whole lot of configuration drift, that didn't take too long at all. And let me switch back to the slide deck. Okay, well that's everything I had. I'm on Twitter. There's my address as well as email, blog, and website. So if you have any questions about either PowerShell Deployment Toolkit or Desired State Configuration, I tweet and blog as much information as I can as we come across new deployment methodologies, and just try to get as much information out to the community as I can. Any questions?
Well, it looks like the queue is empty. Nice session, Joe. What a great info there.
Great. Well, thank you very much, everyone.
Yes, it was awesome.